Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient Metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee due at signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
This is SpaceTime Series 24, Episode 74, for broadcast on the 30th of June 2021. Coming up on SpaceTime, are supermassive black holes collapse dark matter halos? Sentinel 6's ocean data starts flowing. And Juno detects a new Jovian high-energy radiation source. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that supermassive black holes could be formed from the collapse of dark matter halos. Black holes are points in space known as singularities, which consist of infinite density and zero volume. A place where gravity is so great, escape velocity exceeds 300,000 kilometers per second, the speed of light in a vacuum and the ultimate speed limit in the universe. And since nothing can travel faster than the speed of light, nothing, not even light, can escape a black hole. Astronomers already know that stellar mass black holes are formed in the runaway collapse of massive stars much bigger than the Sun at the end of their lives. However, the origins of larger supermassive black holes, which can be millions to billions of times the size of stellar mass black holes, are more difficult to explain. Supermassive black holes are found at the centers of most, if not all, galaxies. The leading hypothesis has always been that they formed from the merger of many smaller stellar mass black holes over cosmic time. But that doesn't stand up to examination. See, as we look further back in time, we can see the existence of supermassive black holes in the very early universe, when there simply wouldn't have been enough time for them to grow that big that quickly. Another hypothesis suggested they were formed directly out of the collapse of gas and dust in the superdense environment in the galactic center. However, new observations suggest that this mechanism still can't produce enough seed black hole material. That is, unless the seed black hole experienced some sort of extremely fast growth rate. Now, a report in the astrophysical journal Letters has suggested a new possibility. Supermassive black holes could be created out of the collapse of a dark matter halo. A dark matter halo is a halo of invisible matter surrounding a galaxy or a cluster of galaxies. Although scientists have never actually seen dark matter and have no idea what it's made out of, they've seen its gravitational impact on galaxies, preventing them from spinning apart as they rotate. In fact, estimates suggest up to 85% of all the matter in the universe is dark matter. And gravitational lensing suggests that it forms halos around galaxies, or more probably, galaxies are formed within the halo of dark matter. The new study's authors suggest that if dark matter has self-interaction, then the gravithermal collapse of a halo of dark matter could lead to the creation of a seed supermassive black hole, and the supermassive black hole's growth would then be more consistent with general expectations. So how would all this work? Well, according to the authors, a self-interacting dark matter halo would experience gravithermal instability, and its central region would then collapse into a seed black hole. The dark matter particles first cluster together under the influence of gravity and form a dark matter halo. During the evolution of the halo, there are two competing forces, gravity and pressure. While gravity pulls dark matter particles inwards, pressure is pushing them outwards. Now, if dark matter particles have no self-interaction, then as gravity pulls them towards the central halo, they become hotter. That is, they move faster. The pressure increases, causing them to bounce back. However, in the case of self-interacting dark matter self-interactions can transport the heat from those hotter particles to cooler ones nearby. and they say that would make it difficult for dark matter particles to bounce back. As the central halo collapses to form a black hole, it would have angular momentum, in other words, it rotates. And the self-interactions would induce viscosity or friction that would dissipate that angular momentum. During the collapse process, the central halo, which is a fixed mass, would shrink in radius and slow down in rotation due to the viscosity. And as the evolution continues, the central halo eventually collapses into a singularity, the seed black hole. And this seed can grow more massively by accreting surrounding baryonic, that is normal visible matter, such as gas and stars. The authors say the advantage of their scenario is that the mass of the seed black hole will be high. That's because it's produced by the collapse of a dark matter halo to grow into a supermassive black hole over a relatively short timescale. The new work's novel in that the researchers identify the importance of baryons, that is ordinary atomic and molecular particles, in order for the idea to work. They say the presence of baryons such as gas and stars can significantly speed up the onset of gravitothermal collapse of a halo, and so a seed black hole could be created early enough. It also shows that self-interactions can induce viscosity, which dissipates the angular momentum remnant in the central halo. And it also provides a method to examine the condition for triggering general relativistic instability of the collapsed halo, which ensures that a seed black hole could form under the right conditions. This is SpaceTime. Still to come, Sentinel 6's ocean data starts flowing, and NASA's Juno spacecraft detects a new Jovian high-energy radiation source. All that and more still to come on SpaceTime.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee to its signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You can even call your aunt who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. US Cellular, built for us. Visit your US Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
After 6 months of checkout and calibration in orbit, the Sentinel 6 spacecraft has started providing its first data streams on the world's oceans and how they're being affected by global warming. Launched last November, the joint NASA-European Space Agency satellite is designed to measure sea surface heights, wind speed and wave heights from over 90% of the world's oceans. These data streams will allow scientists to map changes in sea levels, highlighting anomalies faster and with greater accuracy. Sentinel 6A is the first of 2 satellites developed as part of the Copernicus Sentinel-6 JSON Continuity of Service mission. The second satellite, Sentinel 6B, is slated for launch in 2025. Together, they're the latest in a series of spacecraft which have been gathering precise ocean height measurements for nearly 30 years. Shortly after its launch, Sentinel 6A moved into an orbital position trailing the JSON 3 sea level reference satellite by 30 seconds. Scientists and engineers have been cross-calibrating the data collected by the 2 satellites to ensure the continuity of measurements between them. Scientists use the sea surface height data to gauge how fast sea levels are rising around the world. The measurements also help forecasters predict things like ocean currents and potential hurricane strength. More than 90% of the heat trapped in the Earth's system due to increasing concentrations of greenhouse gases is absorbed by the ocean, and this heat causes seawater to expand. In fact, the expansion of seawater accounts for about 1/3 of modern-day sea level rise, while meltwater from glaciers and ice sheets accounts for the rest. The rate at which the oceans are rising has accelerated over the past 2 decades, and researchers expect it to further speed up in coming years. Sentinel-6 project scientist Josh Willis from NASA's Jet Propulsion Laboratory in Pasadena, California, says several months from now, Sentinel-6A will take over from its predecessor Jason 3, and this first data release is the first step in that process.
Spend a few minutes on any beach and you'll realize just how much the ocean can transform the shoreline. I'm Josh Willis, project scientist for the Sentinel-6 Michael Freilich satellite, a new Earth-observing satellite that will give us the ability to track and understand sea level rise like never before. We're here at NASA's Jet Propulsion Laboratory, and we're really excited about this new satellite. It will extend the record of sea level rise another decade past the 30 years we already have, and allow us to see how sea level is not only rising, but how it's accelerating. This has huge consequences for the planet because sea level rise is one of the most important consequences of human-caused global warming. Sea levels are rising at a faster and faster rate every decade. We need these measurements to help us predict how quickly flooding will increase across the planet. Sentinel-6 will also bring us higher resolution measurements of sea level, which is incredibly important near the coastline where currents are narrow and changes can be difficult to observe from space.
Currents in the ocean tilt the sea surface, making sea level high on one side and low on the other. Also, warm water stands taller than cold, so sea level measurements tell us about both ocean currents and ocean heat.
Ocean currents affect our daily lives because the ocean has a strong impact on climate. In the west, the Pacific Ocean strongly determines droughts and rainfall, and in the east, hurricane forecasting uses satellite altimetry to help predict how much hurricanes will intensify. Ocean conditions can change quickly, and forecasters need data in near real time to predict how currents and marine weather will change across the globe. We're excited about the technical capabilities of this new satellite and the prospect of another 10 years of sea level measurements.
That's Sentinel-6 project scientist Josh Willis from NASA's Jet Propulsion Laboratory in Pasadena, California. And this is SpaceTime. Still to come, Juno detects a new Jovian high-energy radiation source. And America launches 3 new spy satellites on a converted nuclear missile. All that and more still to come on SpaceTime. NASA's Juno spacecraft has discovered a new high-energy radiation source in Jupiter's radiation belts, which are already considered the most intense in the solar system. The spacecraft orbits the gas giant in a highly elongated polar orbit designed to slide between the Jovian radiation belts, avoiding as much of Jupiter's damaging radiation as possible, and then swooping down to skim just 3,400 kilometers above the swirling Jovian cloud tops before swinging back out to more than 8 million kilometers. To further protect Juno from Jupiter's deadly radiation, the spacecraft's most delicate instruments and control systems are housed in a specially shielded strongbox. Juno's unique orbit takes it closer to the solar system's largest planet than any other spacecraft has ever done. This has allowed it to undertake the first complete latitudinal and longitudinal study of Jupiter's radiation belts. And it's that which has resulted in the discovery of this new population of heavy, high-energy gigaelectron-volt ions trapped in Jupiter's mid-latitudes. Rather than using a particle detector or spectrometer, the authors made their discovery using a new technique involving the spacecraft's star tracking camera system to observe and quantify the ions. Star trackers, technically called stellar reference units, are high-resolution navigational cameras designed to compute a spacecraft's precise orientation based on the position of known stars in the sky. The star trackers on Juno are among the most heavily shielded components on the spacecraft, with 6 times more radiation protection than any other systems in the radiation vault. Yet despite its heavy protection, ions and electrons with very high energies still occasionally penetrate the shielding, hitting the stellar reference unit's sensor. The authors focused on 118 unusual events that seem to have hit harder than typical penetrating electrons. A combination of computer modelling and laboratory experiments allowed the authors to determine that these heavy ions hit with between 10 and 100 times more energy than the usual penetrating protons and electrons, which are usually the most common radiation particles. And further computer simulations allowed the scientists to determine the types of particles responsible for these higher energy radiation impacts, finding that ion species ranging from as light as helium up to as heavy as sulfur could account for at least some of the observed impacts. And even the less massive end of the range, say helium through to oxygen, could still account for all of the strikes if they hit with enough energy, in excess of say 100 megaelectron volts per nucleon. The study also determined that these higher radiation areas were in the inner region of Jupiter's synchrotron emission region, which is located between 1.12 and 1.41 Jovian radii out at magnetic latitudes ranging from 31 to 46 degrees, a region that hadn't previously been explored. Juno was launched back on August 5, 2011 from Cape Canaveral on a mission to study the chemical composition of Jupiter's immense atmosphere and cloud structure, peering deep below the obscuring cloud tops, probing convection currents and the thermal engines driving its circulation patterns and spectacular surface weather features, its cyclonic storms, and its iconic salmon and cream coloured atmospheric bands. Juno has also measured Jupiter's gravity field in order to better understand its internal structure. And it's studying its magnetic field, polar magnetosphere, and auroral activity. The 3,625 kilogram spacecraft achieved Jovian orbit insertion on July 5, 2016. The original plans called for a total of 37 orbits around the 143,000 kilometre wide planet, with the original 53.4 Earth day polar orbits eventually contracting down to just 14 Earth days. However, those plans were scrapped following concerns about the spacecraft's main engine, meaning that all the orbits would remain at 53.4 Earth days, and that should have meant fewer overall orbits. The good news is that Juno's been coping with Jupiter's extreme radiation belts better than expected, and that's allowed the mission to extend to its original 37 orbits. This is SpaceTime. Still to come, America launches 3 new spy satellites on a converted nuclear missile. And later in the science report, researchers say that drinking coffee could be good for your liver. All that and more still to come on SpaceTime.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee due at signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast has been a busy place of late, with back-to-back rocket launches taking place. First to fly were the classified intelligence and surveillance gathering NROL 111 payloads for the National Reconnaissance Office aboard a Northrop Grumman Minotaur 1 rocket from Pad 0B.
LCCD-1 VM verify autosequencer started.
Autosequencer started.
PCC activate ARM enable.
ARM enabled.
PCC ARM ODMs.
ODMs ARM.
PCC ARM Orions.
Orions ARM.
PCC ARM boosters.
Boosters ARM.
Copy that.
VMs go for launch.
Copy. Checks 5. Mark. 4, 3, 2, 1. Marking 21 years of Minotaur launches and 15 years of partnership with NASA Wallops Flight Facility and Mid-Atlantic Regional Spaceport.
Vehicle supersonic. Vehicle power is nominal.
Mach 2.
Approaching max Q, attitude nominal.
Mach 3, stage 1 thrust is over 200,000 pounds.
NASA PM copies.
Mach 4, vehicle is now half its original mass.
Stage 1 step, stage 2 ignition confirmed. Motor nominal.
Vehicle flight path and attitude are nominal.
Vehicle avionics and power system are performing as expected.
Vehicle flight path and attitude are nominal.
Approaching stage 2 burnout, vehicle is now 1/4 its original mass.
Stage 2 burnout confirmed.
The US Space Force provided launch services for the 3 top-secret payloads, which were successfully placed into orbit. The mission was the third small-launch US Space Force flight from Wallops Island and the second dedicated National Reconnaissance flight from Wallops in the past 12 months. The National Reconnaissance Office is the intelligence community element and a Department of Defense agency responsible for developing, acquiring, launching and operating America's spy satellites. The 21-metre-tall Minotaur 1 launch vehicle uses a pair of solid fuel rocket engines from decommissioned Minuteman intercontinental ballistic missiles for its lower stage and 2 solid fuel commercial rocket engines for the upper stages. The NROL launch was followed a few days later by the flight of a NASA Terrier improved Orion suborbital sounding rocket carrying part of the Rock On educational school science payload. The mission included more than 70 middle school, high school and university experiments. The sounding rocket flew the student experiments to an altitude of nearly 120 kilometres or 386,000 feet on a ballistic suborbital trajectory. The experiments were returned to the surface by parachute, splashing down in the Atlantic Ocean, from where they were recovered by a pre-positioned boat which had been waiting downrange. Another 34 Rock-On experiments will make their journey to the edge of space aboard a science platform on a special high-altitude NASA scientific balloon, which will launch from Fort Sumner in New Mexico later this year. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that climate change is killing wildlife because when wild animals are hot, they eat less, a potentially fatal phenomenon that has been largely overlooked until now. A report in the journal Trends in Ecology and Evolution has found that hot weather puts all animals off their food. Humans deal with it fairly well because they usually have plenty of fat reserves and lots of different food options. But it's much more serious for animals, especially those with highly specialised diets. If they don't eat regularly, they simply don't meet their nutritional requirements to stay alive. And Australia's iconic marsupials, animals like the greater glider, also get most of their water from their food, so not eating also means dehydration. The findings by scientists from the Australian National University means climate change could be contributing more to deaths among Australian wildlife than had previously been thought. A new study has shown that drinking coffee doesn't just help you kickstart the day, it could be good for your liver as well. A report in the Journal of the British Medical Council Public Health has found an association between coffee and a reduced risk of developing chronic liver disease and related liver conditions. And the authors found the effects were just as good for both caffeinated and decaffeinated coffee, and it didn't matter if the coffee was ground or instant. The authors say that compared to people who didn't drink coffee, coffee consumers had a 21% reduced risk of chronic liver disease, a 20% reduced risk of chronic or fatty liver disease, and a 49% reduced risk of death from chronic liver disease. Scientists believe that higher levels of carwol and kaffir in ground coffee could be playing a part, as these ingredients had previously been shown to be beneficial against liver issues. However, instant coffee, which has low levels of these two ingredients, was also found to be beneficial, which means there must be other ingredients in coffee which are also playing a part. A new study has found that simply opening a plastic bag or bottle is enough to worsen the world's growing problem of microplastic pollution, and potentially affecting human health. The findings, published in the journal Scientific Reports, have shown that opening plastic packaging, such as plastic bags and bottles, generates small amounts of microplastics, plastics less than 5 millimeters long. Scientists tore open chocolate wrappers, cut adhesive tape, and opened plastic bottles, and then used chemical tests and microscopes to assess the microplastics released. They found that while cutting or twisting around 3 meters of plastic, around 10 to 30 nanograms of plastics were generated. A new study has found that medium-sized dinosaur predators would disappear from areas where tyrannosaurs dominated. The findings, reported in the Canadian Journal of Earth Sciences, supports earlier anecdotal reports of a dramatic drop-off in diversity of medium-sized predator species in communities dominated by Tyrannosaurus rex and its close relatives. At the same time, paleontologists found that the diversity of prey species did not decline, and that suggests that medium-sized predators didn't disappear because of a drop-off in their prey. The findings follow earlier studies showing that young tyrannosaurs were faster and more agile than their parents and likely hunted prey similar to that eaten by faster, more agile, medium-sized dinosaurs. It seems that as tyrannosaurs evolved and grew to dominance, their juveniles simply outcompeted other carnivorous dinosaurs in the middle-size range. TLC are about to introduce the new wearable monitors, basically a pair of glasses fitted with two 1080 mini OLED screens. With the details, we're joined by technology editor Alex Hauer-Voigt from ITY.com.
Yes, well, TCL has launched a product called the TCL NextWear G. These are glasses, but these are not AR glasses. These are not VR glasses. These are simply effectively a monitor that you put onto your head, but with glasses. So they look like a pair of sunglasses. And you look into them, you've got a pair of Sony Full HD OLED displays, one on either side, and it looks like a 140-inch display 4 meters from your face. The glasses themselves are 100 grams. The cable, the USB-C cable, is 30 grams, so there's no Wi-Fi, there's no battery, there's no onboard processor. It's just a display, and it plugs into any device that can output to a USB-C video, which is most devices these days that have USB-C can use this as a portable monitor. And it doesn't block your vision. So you can look down, you can look to the sides, you can see if the kids are running around, or if you're on a bus or a train, you can see if people are next to you. No one's going to bunk you over the head with something to try and steal them from you. And they'll be on sale in Australia. They'll be $899. And in the future they'll have wireless versions, and no doubt later this decade we're going to see the AR and VR glasses from Apple. But I remember seeing these sorts of glasses from 20 years ago. I had a VGA version that did 640 by 480, had the VGA plug. It was sort of very primitive. I've actually used these glasses a couple of months ago at an event that TCL had where they were showing some of these things off, and I wish I could have walked out the door with one of them. I mean, it was just very cool. So it's been a bit of a wait for when they were going to appear, but Australia will be pretty much one of the first places in the world to get it, and I'm looking forward to it, and I think it'll be very popular.
And that's Alex Hauer-Voigt from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.